Hello student, good morning. I am Dr. A.K. Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have discussed up to separation of mixtures. Now I will discuss different laws related to atom, molecules and its reaction. First, I will discuss law of conservation of mass. Law of conservation of mass. In all physical and chemical change, the total mass of the reactants is equal to that of the products, or matter can neither be created nor destroyed. This is called law of conservation of mass. Again I am telling you, in all physical and chemical chains, the total mass of reactants is equal to that of the products, or matter can neither be created nor destroyed. This is called law of conservation of mass. Second law I am telling you, law of constant composition or definite proportions. Law of constant composition or definite proportion. What is this law? Listen. A chemical compound is always found to be made up of the same elements combined together in the same fixed ratio by weight. This is called law of constant composition or definite proportion. Again I am telling you, a chemical compound is always found to be made up of the same elements combined together in the same fixed ratio by weight. A chemical compound is always found to be made up of the same elements combined together in the same fixed ratio by weight. Now next law is law of multiple proportions. What is this law? When two elements combine together to form two or more chemical compounds, then the weight of one of the elements which combine with a fixed weight of the other bear a simple ratio to one another. When two elements combines together to form two or more chemical compounds, then the weights of the one element which combine with a fixed weight of the other bear a simple ratio to one another. This is called law of multiple proportions. I will discuss all the things with examples when I will discuss numericals. Now next law is law of reciprocal proportions. Law of reciprocal proportions. What is this law? The ratio of the weights The ratio of the weights of two elements A and B which combine with a fixed weight of the third element C is either the same or a simple multiples of the ratio of the weights of A and B which directly combine with each other. Again I am telling you, the ratio of the weights of two elements A and B which combine with a fixed weight of the third element C is either the same or a simple multiple of the ratio of the weights of A and B which directly combine with each other. Okay, this is called law of reciprocal proportion. Now next law is Gay-Lussac's law of gaseous volumes. Gay-Lussac's law of gaseous volumes. What is this law? When gases react together, they always do so in volumes which bear a simple ratio to one another and to the volumes of the products. If gaseous, all measurements are made under the same condition of temperature and pressure. Again I am telling you what is the Gay-Lussac's law of gaseous volumes. It is related to gas. This law is related to gas. Law is when gases react together, they always do so in volumes which bear a simple ratio to one another and to the volume of the products. If gaseous, all measurements are made under the same condition of temperature and pressure. Okay. Here reactant and products both you have to consider. Okay. Then this is actually Gay-Lussac's law of gaseous volume. This reaction is for gaseous reaction. Reactant and product, it will correlate both. Okay. When gases react together, they always do so in volumes which bear a simple ratio to one another and to the volume of the products. If gaseous, all measurements are made under the same condition of temperature and pressure. Now next I am going to discuss Avogadro's hypothesis. Avogadro hypothesis. What is this? Equal volume of all gases under same condition of temperature and pressure contain equal number of molecules. This is called Avogadro's hypothesis. Okay. Again I am telling you, equal volumes of all gases under similar condition of temperature and pressure contain equal number of molecules. Already all the things I have discussed in the proper places in the previous lectures in details. Now don't forget, here only I am just reviewing entire chapter. First chapter I am going to review. After that different questions will be discussed, including numericals and other, you can say, questions that is a different pattern. Many questions are in many pattern. Then every pattern I will discuss. Then before solving the problems, numericals, you have to understand the entire chapters. What are the facts of full chapter? Now next I am going to discuss, that is the atom. Atom already you know, but I am briefing it because I am reviewing entire chapter. Atom. What is the atom? It is the smallest particle of an element. A smallest particle of an element or a compound that is capable of free existence. It should exist freely. Okay. It is the smallest particle of an element. Atom I am talking about, it is the smallest particle of an element that takes place in a chemical reaction. It may or may not be capable of free existence. Okay. After that I will come to molecules. Atom, again you understand, atom is the smallest particle of an element that takes place in a chemical reaction. It may or may not be capable of free existence. And what is the molecule? Then molecule is the smallest particle of an element or a compound, both. Molecule is the smallest particle of an element or a compound that is capable of free existence. Free existence. Then molecule, you know that actually atom generally will exist in combined form. Atom generally exists in combined form. Okay, always you will not get in free state. Exception is there. That is the last group. Inert gases, helium, neon, argon, krypton, radon, xenon, all are atom. All are monoatomic gas. Correct? You can find it in free state. But hydrogen will you get? Chlorine will you get? Oxygen will you get? All you will get in combined state. Okay. Hydrogen you will get in the form of water. Correct? Like that way oxygen will get O2 in the form of O2. Correct? 2O is there. Or H2O. H2O. But here this also you can take example Cl2, Br2, I2. That is existing only in the molecular form, not in atomic form. Only this group 18 inert gases exist in atomic form. That's why definition is like that. Atom definition I told you, it is the smallest particle of an element that takes place in a chemical reaction. It may or may not be capable for free existence. Correct? And molecule is the smallest particle of an element or a compound that is capable of free existence. Then molecule, all molecules you are getting, all are existing, capable of existing in free state. All molecule H2, N2, Cl2, O2, whatever you will take the name, all molecules are capable of free existence. But atom may or may not. May or may not. Generally you will not get. Only this inert gases, group 18, only there you will get atom in free state. Okay. Otherwise, always you will get in combined form. Now, what is the atomic mass unit? Next, A.M.U. Then atomic mass unit, A.M.U. A small a, small m, small u. Then this you understand very easily. You can understand that atomic mass unit is equal to 1/12 of the mass of an atom. An atom. Correct? Which atom? Which atom? Then carbon atom. Carbon atom. Then carbon atom now it has 3 isotopes. C12, C13, C14. But C12 is found in more quantity. Correct? That's why that carbon C12 isotope is considered. Then 1/12 of the mass of the atom. Which atom? Then carbon 12, C12. What is its mass? That's 12th part, 1/12 of this mass. You remember. Okay, don't memorize, you remember. 1/12 of carbon, but carbon should be C12. Okay. Then this atomic mass unit is equal to 1/12 of the mass of an atom of C12. And what is its value? It is equal to 1.6606 into 10 to the power minus 24 gram. Don't forget. This you have to remember always. This will help you in solving the numericals. A.M.U. Okay. Then this value 1.6606 into 10 to the power minus 24 gram. That is equal to 1 A.M.U. 1 A.M.U. is equal to 1.6606 into 10 to the power minus 24 gram. Okay. Then atomic mass unit is equal to the 1/12 of the mass of an atom of C12. It is equal to 1.6606 into 10 to the power minus 24 gram. Now, what is the atomic mass? This is the atomic mass unit, A.M.U. Okay, but what is the atomic mass? Many atoms are there. Many atoms are there, hydrogen, oxygen, nitrogen, correct, chlorine, chlorine, bromine, iodine, 118 are there till date. Then, what is the atomic mass? Then it is the average relative mass of its atoms as compared with an atom of carbon 12. Carbon 12 means C12 isotopes taken as 12. Okay. This atomic mass, any other metal, any other element, atomic mass, many atoms, different atoms are there. Then for any atoms I am talking about, atomic mass is the average relative mass. Relative mass, remember, you are comparing. It is the average relative mass of the atoms as compared with to from whom you are comparing. Then comparing with carbon C12, you are comparing in respect of this carbon. Correct? Down you write, upside to whom you write, to whom you want to know that you write, and down is this carbon C12. In comparison to this 12, how much it is the mass of that carbon in comparison to this. Okay, that you remember. Then atomic mass is the average relative mass of its atom as compared with an atom of carbon 12 isotopes. C12 isotopes taken as 12. That is taken as 12. Okay. You have to compare with this carbon mass of this C12. Correct? You have to compare. Atomic mass is the average relative mass of its atoms as compared with an atom of carbon 12 isotopes taken as 12. How will you do calculation? Calculation of average atomic mass, how will you calculate? Then here you should understand calculation is very conceptual. If an element exists in two isotopes, if an element exists in two isotopes having atomic masses A and B, small a and small b, in the ratio m is to n, small m is to n, small n. Correct? Two isotopes, suppose if an element exists in two isotopes having atomic masses A and B and ratio they are found in, suppose m is to n ratio, then average atomic mass will be what? Then average atomic mass will be, you add the total mass. Okay, A is found in m number and B is found in n number. Then m into A plus n into B divided by total number m plus n. Correct? M into A plus n into B. Now total mass you understood? Then total number was m plus n. A was in m number, B was in n number. Then add both number m plus n. Then for this number m plus n number, total mass is how much? M into A plus n into B. Then divide it. This total mass you divide by m plus n. Correct? Then now you can write average atomic mass is equal to formula wise m into A plus n into B divided by m plus n. This is called average atomic mass. Question is asked. This is the, you can say, formula. Only on this formula you can calculate average atomic mass. Now next is gram atomic mass. Gram atomic mass. What is the gram atomic mass? The atomic mass of an element expressed in grams is called gram atomic mass. This amount of the element is called 1 gram atom. See, remember here, 1 gram atom. It is not like that you are weighing only 1 gram. Here 1 gram atom means gram atomic mass. You have to, atomic mass you should know. Correct? The mass of the atomic mass, that atomic mass actually is called 1 gram atom. You don't forget. Many students will think that only that you have to take the weight of 1 gram. Correct? Not like this. 1 gram atom means, 1 gram atom means not only 1 gram. Okay, not only 1 gram of any element, of any atom. 1 gram is different. 1 gram atom is different. 1 gram atom means you are talking about gram atomic mass. Atomic mass, when you will express in gram, then it is called gram atomic mass. Means molecular weight is equal to 1 gram atom. Remember, okay, it is expressed in two ways. First, gram atomic mass, and also called 1 gram atom. Only 1 gram is different, 1 gram atom is different. Then gram atomic mass you can define as the atomic mass of an element expressed in grams is called gram atomic mass. This amount of the element is called 1 gram atom. Now next I am telling you difference between atomic mass and actual mass of an atom. What are the difference? Difference between atomic mass and actual mass of an atom. Now listen here. The atomic mass of an atom, of element you can tell, the atomic mass of an atom or element you can tell, is not its actual mass. Correct? Atomic mass of an atom or element is not its actual mass. It is a relative mass as compared with an atom of carbon 12. Okay, carbon 12. In comparison to that, you are talking about atomic mass. When you are comparing with carbon taken as 12. Carbon 12 isotopes you should take as a 12. Okay, the atomic mass of an atom is not its actual mass. It is a relative mass, means comparing. It is the relative mass as compared with an atom of carbon taken as 12. It is expressed in A.M.U. What is the actual mass? The actual mass of an atom means its mass in gram, which is obtained by dividing the atomic mass of the elements by Avogadro number. That is 6.02 into 10 to the power 23. Okay. This Avogadro number is 6.02 into 10 to the power 23. Then if you will divide it by this number, if you will divide atomic mass, means you just understand the actual mass of an atom means its mass in gram, which is obtained by dividing the atomic mass of an element by Avogadro number. Okay, because 1 gram atom contains a Avogadro number of atoms. You remember, 1 gram atom means Avogadro number of atoms. That's why we want to know the mass of one atom. Then you should divide by Avogadro number. Then you will get the mass of one atom. Mass of one atom, 1 gram atom. Okay, 1 gram atom means Avogadro number of atoms. Hence, actual mass of an atom means its mass in gram, which is mass in gram, which is obtained by dividing the atomic mass of the element by Avogadro number. Correct? Atomic mass of the element divided by Avogadro number, that is the 6.022 into 10 to the power 23. Correct? Because 1 gram atom contains Avogadro number of atoms. You remember, this concept is very, very useful when you will solve the numericals. Okay. Now, molecular mass. What is the molecular mass? Then just like atomic mass, you can divide molecular mass. Molecular mass of a substance is the average relative mass of its molecules as compared with an atom of C12 isotope taken as 12, means In comparison to 12, you have to take C12. C12 means 12. Okay. Then molecular mass of an isotope is the average relative mass of its molecules as compared with an atom C12. An atom of C12 isotopes taken as 12. See, now you will ask the question, why C12? Why not others? Correct? Then it was actually in the beginning. In the beginning, oxygen they were considering as this thing, a standard. But now, later on, they found that now carbon is found everywhere. Correct? Everywhere it is available. Then now they change this standard. Because anything you have to tell anything, so you have to consider one standard. And in comparison to that, you can tell anything. In the world, always what you are knowing, that is just you are comparing with some standard that is considered by scientists. In comparison to that, anything you are telling that this body has so much gram, kg mass. Whenever you are using the term kg or anything ton or anything gram, it means in comparison to some things you are telling. Correct? They have considered 1 kg means this. Simply they have considered. Simply. In comparison to that, always you are talking. What they have considered, that is a standard. Same thing for length. They have considered one, can say, rod. Correct? Whose length can't increase at normal temperature. Then all things they have considered. For time, same things. Correct? For time, for mass, like that way for everything. Some standard is fixed. In comparison to that, you are talking about. Okay. Then here is the same things. Atomic mass or molecular mass. Then molecular mass of a substance is the average relative mass of its molecules as compared with an atom of C12 isotopes taken as 12. What is the gram molecular mass or molar mass? Then how easily you can tell the molecular mass of a substance expressed in gram is called gram molecular mass or molar mass. The amount of the substance is called 1 gram molecule. Here also, just like 1 gram atom, you are talking about 1 gram molecule. Like NH3. NH3, you add all N, atomic mass of N and atomic mass of H. 3H is there. Correct? Then whatever you will get, NH3, N means what? 14 plus 3H, 3, 17 total. Then 17 gram means you are talking about 1 gram molecule. Same thing is in the case of 1 gram atom. 1 gram atom, same concept. 1 gram atom or 1 gram molecule. Now, what is the difference between molecular mass and the actual mass of a molecule? Then what I have explained, it is similar to that what I have discussed. Okay. That is the difference between molecular mass and actual mass of a molecule. Because it is you are comparing always with difference between atomic mass and actual mass. What I discussed, that is the atomic mass of an atom is not its actual mass. It is a relative mass as compared with an atom of carbon taken as 12. Same way here also with molecules. Now, actually today I am stopping only here. Next class again I will discuss another terms. Thank you.